All right, so 13.8, we're doing reciprocal trig. Again, keeping up with notes, this would be number 11. We're doing dates, 2/12/21. And what we're going to do is actually we're going to kind of review some stuff before we get to where we need to be to get to the actual reciprocal trig stuff on this one. So first thing we're going to do is we're going to talk about rationalizing the denominator. And you may or may not have heard of that before. If you have, that's great. If you haven't, that's fine too. We're going to show you how to get through this thing. And honestly, if you can kind of realize what we're doing here, this is the hardest thing we've got to do in the trig sections that we're going to do. At least it seems that way to me. All right, so rationalizing denominators. Here's basically what you're going to do. You're going to eliminate the radical. And again, we're talking about radical for everything we're doing right now. That's your square root symbol. So we're going to eliminate the radical in the denominator. And to do that, we're going to multiply the numerator and the denominator So we're eliminating the radical in the denominator. We're going to be multiplying the numerator and the denominator. We're going to multiply by the radical that is in the denominator. Okay, and we're going to do a couple examples and show you kind of the long way of doing it, and then we're going to show you the shortcut because, I mean, that's what the shortcut's there for. It makes things a little bit quicker, a little bit faster, a little bit easier when we go through. All right, so here we go. So let's start with something like this. Let's say you have 1 over the square root of 2. Okay, so we're going to take the 1 over square root of 2, and again, whatever square root you have in the denominator, whatever the radical is that's there, we're going to multiply by that number. If you do 1 times the square root of 2 on the top, that is square root of 2. And then one thing we're kind of jumping ahead of a little bit because we're doing this out of order a little bit. If you're doing radicals and you're multiplying together, you take what's on the inside and you multiply it together. So if we've got square root of 2 times square root of 2, that just makes it square root of 4. But what is square root of 4? That's just 2. There you go. So that becomes square root of 2 over 2. Okay. And again, the biggest thing is that when we do some of these things, because again, it's going to be a little while before we get there, but if you start adding and subtracting radicals together, and you don't have to write this down, but if you start adding and subtracting radicals together, if you start trying to figure out how you're going to do like 4 over the square root of 5 plus 6 over the square root of 3, most people look at that and they go, yeah, I don't know. Don't have a clue with that one, how to do that. So if we can take these radicals we have and change it so that this becomes a 5 and this becomes a 3, and we start adding and subtracting, it's a lot easier to get common denominators if you've got just numbers instead of having just radicals, because the radicals just throw people off when we do this one. So that's the main thing we're trying to do, is we're trying to make it so that if at some point in time down the road when we have to start adding and subtracting, it's going to be a lot easier to do this to get to what we're going to do, to get what we need to go through to get there. So, all right, so example 2. All right, let's say it's 7 over the square root of 3. Okay, so again, we're going to take the original problem we have. We're going to multiply the top and the bottom by square root of 3. So that makes it 7 square root of 3 over square root of 9. And when you square root 9, that would just be 3. Okay. So that would be what the answer rationalize. And again, rationalize just means there is no square root in the denominator, which makes things a little bit easier if you have to start adding and subtracting radicals when you go through this thing. All right, here's the shortcut. I mean, and that's not really a long process, so it's not anything huge. But here's something that's even better when it comes off of it. Here's the shortcut. You're going to move the square root of whatever the number is from the bottom to the top. And you leave just the number in the denominator. Okay, and if you look at the two examples that's above here that we did, that's kind of what we did. We had 7 over the square root of 3. We moved the square root of 3 from the bottom to the top. On the bottom, we left just the number. Same thing here. We took the square root of 2 from the bottom to the top. On the bottom, you leave just the number. Okay, now, and that only works for square roots. If you start doing later on, eventually, if we go in with some of the radicals we get to, sometimes this may be a third root or a fourth root or something like that. It changes things, but as long as we're doing square roots, that's the shortcut you can do on this. So if we want to throw a shortcut at you problem here, let's say you have 5 over the square root of 7. Okay, so shortcut says we take the square root of 7, we move it from the bottom to the top. On the bottom, you leave just the 7. And people go, yeah, I like that a lot better. Okay. And the reason that works out is that if you multiply on the bottom, if you do 7 times 7, that's going to be 49, which is a perfect square root. When you square root it, you're always going to get that here. And the top part, well, it's just going to work out that way. All right, here's a worst case scenario that might happen. Let's say it's 10 over the square root of 5. Okay, but we're still going to do the same steps. We're going to move the square root from the bottom to the top. On the bottom, you give me just the number. All right, and for just 1 second, what if that square root of 5 wasn't here? What if it was just 10 over 5? We can simplify that, right? We can divide both of those by 5 and make that 2 over 1 or just 2. So if you have some numbers on the outside, when you move all this stuff around, if you've got numbers on the outside, you can simplify. You can simplify that just like a regular fraction. So you actually could make this thing out to be 2 square root of 5. It'd be over 1. But if it's over 1, it doesn't really do anything. So that one we can just make it 2 square root of 5. Okay, so worst case scenario, if you rationalize, when you get to the end, you've got a fraction, you might have to simplify it just a little bit. But it shouldn't be a really big bad fraction. It should be something you can do fairly easy when it comes off of it. Okay, now here's where we're going to kind of use this to kind of walk into what we're doing today. It's kind of a two-part question. I'm going to take you back to middle school, which I know can be a little bit scary. But let's say you had a fraction like this that had a radical in it. Let's say it was 1/2 over square root of 3 over 2. And most people go, ooh, yeah, I don't really like fractions. I really don't like that because we got a fraction on top of a fraction. Okay, so let's take it back to middle school. That back in middle school, what we could have done, we could have rewritten this so it would have been 1/2. Take the big fraction bar you got here. It would have been 1/2 divided by square root of 3 over 2. And hopefully everybody goes, oh, yeah, that looks familiar. And y'all remember what you did from here to make it work out? What did we do from this point? Anybody remember? 3 little letters. Keep it, change it, and flip it, right? Yeah, so once you got to here, you do keep it, change it, and then flip it. So we keep the 1/2, change the division to multiplication, and then we'll flip this thing upside down. So it's 2 over square root of 3. All right, and then same kind of thing before, the 2's would cancel out. Because because we cross cancel those. That makes it 1 over the square root of 3. Now remember, if you're talking about a fraction, this one we had the 1 on the bottom. We didn't need it. If it's a fraction, you have to put the 1 on the top. It has to stay there. 1 on the bottom, you can keep it or not. You can get rid of it. But if it's a fraction and you've got the denominator and just the 1 on the top, you have to keep the 1 on the top because it's there like as a placeholder. If you take this thing away, it's just square root of 3. So, if you kind of think back to some of the numbers you were doing before, if that was, 1 over 5, and people are like, well, I'll just get rid of the 5. Well, would you rather have a fifth of a dollar or $5? A little different, right? So if you've got a 1 on the top, you've got to remember to leave that 1 in there. 1 on the bottom, you can get rid of it. You don't really need it. Once you're here, now we're going to rationalize it just like we were doing before. So now we're going to take the square root of 3, move it from the bottom to the top, and give me just the 3 that's on the bottom. And if you put the 1 here, it's 1 times the square root of 3. But 1 times the square root of 3 is still just going to give you square root of 3. So then that would be the final answer that we're looking for there. Okay, so that's kind of the bridge we're going to. That's more of what we're going to do today. But that's kind of the bridge from when y'all were doing keep it, change it, flip it back in middle school. But now we're going to bring it in and throw it in with the radical so that when you get finished with it, you may have to go back and rationalize this number to make it look something like that. All right, let me show you one more of those, and then we'll jump onto that worksheet. All right, so let's say we've got, straighten up there a little bit, 1 over the square root of 2 over 2. All right, and we'll do basically the same thing. Now, and if you want to, when we start doing some of these in a little bit, we'll do something to save steps a little bit. Instead of writing it out like this, you can also just go straight ahead and do keep it, change it, flip it, just like that. So you'll keep the top number the same, change the big division bar to multiplication, and then we'll flip the bottom number we've got here. So that will give us 1 times 2 over the square root of 2. And you may be saying, well, if you do 1 times it, that's just the number, right? Yes, that's just the number. So it's just 2 over the square root of 2. And then now we can rationalize this thing. So then we'll move the square root of 2 from the bottom to the top. And we'll leave just the 2 on the bottom. Okay. And then cancel out the 2's. So you can finally get the square root of 2. So what starts off looking like a really ugly fraction, when we wind up fixing this thing and rationalizing, it's like, oh, it's just square root of 2. So it looks bad in the beginning, but when we fixed it, it's actually not as bad as we thought it was going to be when we got there. Okay, so that's the big stuff that we've got kind of today. Here's where we're going to kind of come back to the worksheet that we've got that's going on with this. Now, if you want to, you can write this down underneath this one because this is where we're going to kind of add in some new things here. So far, if you go back to yesterday, if you remember, we said that cosine was going to be the same thing as your x value when we're doing ordered pairs. Sine was going to be the y value. And we talked about it, but we didn't do anything with it. This is where we're actually going to do something with it today. Tangent, we said, was sine over cosine. Okay, and everybody remembers that from geometry because that was SOHCAHTOA. We had to do sine and cosine and tangent. I had to do all the opposite and adjacent. It did a little different in geometry because you had to use opposite side and adjacent side and everything on that one. But it's still kind of all tied together with this thing. Here's 3 new ones we have to add in. We've got to talk about secant, which when they talk about it in short, it's just going to be SEC. And for secant, it's going to be 1 over cosine. We're going to talk about cosecant. And the abbreviation for cosecant is CSC. And it's going to be 1 over sine. And then the last one is cotangent. And the short version of cotangent is just going to be COT. Okay, and basically cotangent is the reciprocal of tangent. So where this was sine over cosine, cotangent is just going to be cosine over sine. Okay, so here's what we're going to do. We're going to take, if you've got your unit circle out from yesterday, we're going to take the unit circle and use it to help you answer and pick up on some stuff and see everything that's here. So if you've got your pink sheet, if you want to pull that out, you can. I've got mine here that I've got it filled in because my handwriting gets a little messy sometimes, so I can kind of go back and do that. And we're going to kind of use both of them to show you how to do the homework in 13.1 or 13.2. Anytime it talks about unit circle homework, we're going to show you how to do that one. And this also goes with 13.8. So this is kind of a practice of two sections at the same time, really, is what it comes off of. Okay, so there's that worksheet. We're going to go back and fill this thing in and show you how to make everything work on here. We're going to do the first 3 or 4 together, maybe even 5. We're going to have you try a couple on your own and then kind of go from there. All right, so here's what it's going to be. If it asks you to find the cosine of, and this was the easiest way I could kind of come up with it to get everything we needed to do, but basically if a question is going to ask you to find the cosine of pi over 3, again, what you're going to do is you're going to go to unit circle, you're going to find pi over 3, and cosine is going to be the first number. So the answer to cosine of pi over 3 is just going to be 1/2. Right? And if it asks you to find the sine of pi over 3, same thing. You go to pi over 3. Sine is going to be the second number, so it's going to be square root of 3 over 2. All right, and if it's cosine or sine, it is just that easy every single time if you've got the unit circle in front of you. If it's cosine of pi over 2, we're going to go to pi over 2. Cosine is going to be the first number. So they ask you for the sine of pi over 2. That's the second number. Just put a 1. And people start going, wait a minute. So every single time, cosine is just the first number in the ordered pair, and sine is the second number in the ordered pair. Yes, so if it asks for 2 pi over 3, this would be the cosine, and this would be the sine. So that's all it's going to be. So if we do pi over 6, which is back over here, off the paper here, cosine is going to be square root of 3 over 2. The sine of pi over 6 is going to be 1/2. Okay. Let me do this one. I'm going to have y'all kind of do a couple here and just see what you can do. If we go down to number 6, 330, that's right here. Cosine is going to be square root of 3 over 2. Sine is going to be negative 1/2. All right, now here's what I'd like for you to do. For the other 4, and we'll get to 9 and 10 in just a second, but for 4, 5, 7, and 8, definitely 4 and 5. Go back and put what you think on 4 and 5, and we'll check those real quick. And then we'll kind of do the same thing for 7 and 8, and then we're going to show you how to get to 9 and 10 here in a second. So take like 2 seconds and just check, what you need for square root of 4, for the sine and cosine. So do the same thing for pi. See what numbers you get, and then we're going to check it and make sure you got them in the right place. And we'll do the same thing for the negative 45 and the negative 7 pi over 6. All right, so let's see what we got here. All right, so for square or pi over 4, same number both, right? Square root of 2 over 2, square root of 2 over 2. And for pi, that's at the top, that's at 0, 1. Wait, sorry, that's pi over 2. Pi is over here, that's at negative 1, 0. Okay. All right, negative 45. When you get to the negatives on 7 and 8, it's kind of like we were doing yesterday. That negative 45 is not on the list because everything is positive. So this is where we have to find the coterminal angle type thing. So if it's negative 45, all we really need to do is just add 360 to it, correct? So if we do negative 45 plus 360, that's going to be 315. So basically we'll go to 315. There's our cosine, and there's going to be our sine. That, again, basically what we're doing for that one is that in negative 45, instead of going this way, you've got to come down 45 degrees, which really means you're going to start at 360 and you're going to subtract 45, which will put you at 315 degrees. Okay, so that's this angle that we would have if we were talking about finding this angle that's here. All right, and then same thing for number 8. It's negative 7 pi over 6, and most people aren't real comfortable with that one. But 7 pi over 6 would be 210. So now we're basically going to start at 360, and we're going to do the negative 210. So it's negative 210 plus 360, which would put us at 150. So if we were having to sketch or draw that angle, that would take us all the way back around to here at the 150 mark. And at the 150 mark, we need negative square root of 3 over 2 and then 1/2. Okay, so that's really the only difference of negative angles. Positive angles, you would just be going this way. Negative angles, you're basically starting at 360, and you take whatever the angle is, you add 360 to it, and that tells you where you've got to finish if you were going this way. All right, so here's all right, so what about number 9? 720 is not on the list. But how do we get it from how do we get to a number that is on the unit circle? Just subtract 360, right? So if it's bigger than 360, just subtract 360 from it. This will get you back to 360. So at 360 degrees, it's the same thing as 0. That's going to be at 10. All right, and then the last one, 13 pi over 2. This is kind of tough. I might kind of get you a little sketch going for this one, so let me kind of go off here for a second. For 13 pi over 2, you almost have to change this back into a mixed number. So this would be 6.5 pi. All right, and if you let me just give you a short version of the unit circle here. If we started here at 0, if we get to here, this was 1 pi. So every time we go 180 degrees, that's equal to a pi. So when we get back to 360 degrees, okay, that was 2 pi. All right, if we kept going here, this would be like 500, this would be going another 180 degrees, that would add another pi, so then this would be 3 pi. If we get back to here, just like this problem at 720, well, that's the same answer we had here, but now we've gone around and it's 4 pi. So as long as you keep going around the circle, every time you add pi to it, this will always be an odd pi. This would be an even pi. Because pi is basically the same thing as saying you're adding 180 to it. So this is every multiple of 180. This is every multiple of like 360 if you keep going around for this thing. Okay, so if it's 6.5 pi, if it was just 6 pi, that's going to get you back to here. And then it says, all right, well, now I got to go a half pi more, which is really like pi over 2. Well, the next number that's pi over 2 is right here. So if we go 6 pi, that puts us back here. Then we go to the next pi over 2 number. That's going to put us right here. So this would be the same thing as being like 90 degrees that we're looking for. So 13 pi over 2, if we kept going around the circle, it's eventually going to wind up right back here to be 0, 1 for the cosine and for the sine. Okay, so that one's a little tougher just because it's, if it's in degrees, everybody's all right, we'll just subtract 360, eventually we get back to it. And this one's basically doing the same thing. We're just peeling back the layers of how many times this thing is going around the circle, 2 or 3 or 4 times, and you're just peeling those back so we get it back. So we're just kind of dealing with it going around at one time, kind of along those lines. Okay, now here's where we're going to put your math skills to use. So this is where occasionally you'll get a little from the chicken. Yeah. This is kind of let you know this is the important thing of the day. Sometimes it's if you're asleep, he'll come by and give you a little in your ear, wake you up a little bit. But sometimes I just use this just to be funny. So this is where you want to listen, because this is the important thing of the day when we go through this one. If you can get this, then we're good for everything else we've got to do. All right, for tangent, we said tangent is sine over cosine. So when they ask you to find the tangent of pi over 3, well, if you know what the ordered pair is, that means that for tangent of pi over 3, it's going to be square root of 3 over 2 over 1/2. Okay, and then we're going to go back to what we were doing just a minute ago. We're going to keep it. We're going to change it. And we're going to flip it. So that's going to make it square root of 3 over 2 times 2 over 1. And you go, well, hey, that works out kind of nice because I've got my 2's here. I can cancel out. Yep. So that leaves us with square root of 3 over 1, which again is just square root of 3. And there we go. So this big ugly fraction that started here, when we go back and do a little simplifying, it's just square root of 3. You go, okay, well, that's not too bad. All right, so let's hang on to it for then. Let's do the same thing for the next one. If they ask you for tangent of pi over 2, we've got to do sine over cosine, so that means we're going to put 1 over 0. All right, I'm going to take you back to me for my memories here. When I was in school, if I had a one-question test, and this was the one-question test that they gave to me, I don't know if I could answer this one correct. It'd have been 50-50, right? Because I knew sort of what it was, but I didn't sort of know what it was. I couldn't have got it for sure. You know, if it was $100 question, I don't know if I'd have gotten it. I'd say, hey, can you give me $50 and we'll just call it even? Because it would have been a guess. What I realized was that I didn't realize this till I got to college. I was like, I had the answer sitting in my hand the whole time. Because as much as I couldn't remember if this answer was 0 or undefined, all I had to do was just use this thing. Because everybody's got one of these, right? Or at least you've got something you can get to it. If you can't remember what it is, just punch it in real quick. Do 1 divided by 0. It says, guess what? You can't do that. So this one is undefined. All right, and the big thing on this one is you just got to, once you do enough of these, eventually you kind of get it in your head that if 0 is on the bottom, it doesn't matter what it is, but anytime you divide by 0, it's always going to give you the error message. So anytime it's 0 on the bottom, it's always going to be undefined. And I was one of those that I kind of, you know, I kind of knew it, but I didn't really know it. I just memorized it. I didn't just actually learn it. So it was always kind of trouble with it. But then eventually I figured it out. So, all right, so for this one, same thing. We're going to do 1/2 over square root of 3 over 2. Now, here's where we're going to cheat just a little bit. Because if you look back on the problems we did just a minute ago, we've got this problem right here. We've got the exact same thing. We've got 1/2 over square root of 3 over 2. And yeah, I did that on purpose. I was making that in a cheat sheet for you. We're going to keep it, change it, flip it. We would do all this other stuff. Eventually, we'd come out to square root of 3 over 3. So for this one, we can just go, you know, see previous work. You know, if you put it on the back, you can say, look on the back. If you did it on another sheet of paper, you can do, you know, whatever you did. Wherever you put it, just put a little note saying that's where we did it. But our answer is just going to be square root of 3 over 3. All right, number 4 gets really easy because if we stop and think about it, because we're going to do sine over cosine. What happens when you put the same thing over itself? Just cancels out, right? So if you put like 8 over 8 or 4 over 4, eventually they're going to cancel each other out. Just get a 1. All right, and with number 5, well, it's the opposite of this one. This one was 1 over 0, so this will be 0 over -1. If that one's undefined, if you put 0 on top, doesn't matter what you put on the bottom. If it's any number other than 0, the answer will just be 0. So 0 on the bottom, it's undefined. 0 on the top, it's going to be 0. Now, here's where the magic kicks in for this sheet. When we do number 6, it's square root of 3 over 2 over -1/2. And here's where I want you to see this. And here's where I want you to this is where I want you to use the sheet whenever I ask you to do any of these problems that's in the homework. because this looks a lot like this, right? So if you already know what this answer is, if this is the exact same problem, you don't have to rework all this stuff. You just tell me the answer is square root of 3. Now, you got to check it for positives and negatives, because that's the one thing that might change. You've only got one negative here. We're doing a positive divided by negative, so that means the answer will then be a negative. And that's the great thing, is that once you do a few of the tangent problems, you've done every tangent problem you can possibly do, because there's only so many answers you can get off this thing. When we do number 7, it's negative square root of 2 over 2 over square root of 2 over 2. It's the same thing over itself, so that answer has to be 1. But it's a negative divided by positive, so now it's going to be a negative. So if you have one negative number, the answer is negative. If you happen to get two negative numbers, the answer is going to be positive. When you do number 8, same thing with this one. It's 1/2 over negative square root of 3 over 2. But you've already done that one right here. So you know that this answer has to be the same as this one. This has to be square root of 3 over 3. But one of the numbers is negative, so that means the answer's got to be negative. So every possible answer you can get for tangent, you've got every possible answer right here. And you're like, so you mean I don't really have to work these out? I can just look at this sheet and I can get the answer. Yes. So when you go through the homework, if it asks you for tangent at any point in time, you just go through and find one of these numbers, figure out which one it is. Now, the one thing you have to do is you have to find the sine and the cosine, which should be easy, because that's just getting on the unit circle, finding out where it is. But once you've got these numbers and you make the fraction, you've got every possible answer you could get right here on your sheet, because we've run, that's every single possible answer you could get for tangent when you go through this thing. Because down here we've got zeros and ones, and we've got ones and zeros. Again, this is going to be the same answer we've got here. So this answer would be 0. This answer would be undefined. And that's what I want you to see. You don't have to keep reinventing the wheel every time you do one of these problems, because every time you do one of these problems, it's already been done before. Okay, for secant, we said that secant is going to be 1 over cosine. And what I'm going to do for secant is, I'm actually going to fold this thing back, because we don't need to worry about tangent. We don't need to worry about sine. Whenever we start doing secant, we only need to worry about the cosine value. So I'm actually going to fold my paper back. Y'all don't have to do this. I'm just doing this just for y'all's visual purpose. And we're just going to go back and do it like that. Okay, so when we're doing secant, if you could fold this thing back, we just need the cosine value. So if it asks you for the secant of pi over 3, we would go to pi over 3, get the cosine value, and then the answer we're going to put is going to be 1 over 1/2. And again, we're going to keep it, we're going to change it, and we're going to flip it. So it's going to make it 1 times, well, if we flip a half upside down, that's 2. And 1 times 2 is just 2. All right, second one gets really easy, because it's 1 over 0. Well, we just did that right here, right, for tangent. We know that 1 over 0 is undefined, so we don't have to work this one out, because we just did it. We know that is undefined. All right, for number 3, we might have to go back, and we might have to sneak into cosecant numbers back here, but that's okay, because we'll be fine when we do this one. For pi over 6, if I ask you for secant of pi over 6, it's 1 over the square root of 3 over 2. And again, when you do enough of these, you kind of see the same thing. Again, we're going to keep it, we're going to change it, we're going to flip it. And hopefully you kind of notice that, again, if we do that, it's 1 times 2 over the square root of 3. But because we're multiplying by 1, it doesn't really do anything. That's just 2 over the square root of 3. And here's where we get to rationalize it like we were doing earlier, that when we rationalize it, we're going to move the square root from the bottom to the top. And we're going to leave just the number on the bottom. Okay, and we had to go into cosecant over here, but that's fine because we actually won't even have to worry about this part of cosecant when we get to it. All right, we'll do it one more time with this one. So if we ask for the secant of pi over 4, that's going to be 1 over square root of 2 over 2. And you may go, well, that looks a lot like this one up here, but instead of having square root of 3, we're going to have square root of 2. Yeah, so it's going to basically look about the same way. We're going to keep it, change it, and we're going to flip it. So it's going to be 1 times 2 over the square root of 2, which again, the 1 doesn't really do anything, so it's just 2 over the square root of 2. So then we're going to move the square root from the bottom to the top. On the bottom, we're going to take the square off and give me just the 2. And then you're going, well, wait a minute. We've got 2 on the top and 2 on the bottom. Don't we just cancel those out? Yep, just cancel those out. So that makes it just square root of 2. Okay, and we had to take out that whole box there. We'll be okay. All right, and here's the good news on this one. Pretty much everything else that we're going to do is either going to be really easy or it's going to be a repeat. Because when we do this one, it's 1 over negative 1. And you go, well, that's easy. That's just negative 1. Yep, it is. When we do the next one, it's 1 over the square root of 3 over 2. And you go, well, wait. We just did that right here. We know that answer is going to be 2 square root of 3 over 3. Yeah. And you're like, well, but the next one, that's the same thing as this one right here because they're both square root of 2's. So we know that this answer would just be square root of 2. Yeah. So and this is the thing. Once you've done a few of these numbers, the same numbers just keep popping up over and over and over because there's only so many numbers that's on this unit circle. You only have a half. You only have square root of 3 over 2. You only have a 0 or a 1. That's it. That's all the numbers you got, and you've got the square root of 2 over 2. There's only 5 different numbers that's on the unit circle. Now, again, they could be positive or negative, but there's only 5 basic numbers. It's 0, 1, square root of 3 over 2, 1/2, or it's square root of 2 over 2. So there's only 5 possible answers you can get off this thing. And once you've done this, you've made the list. Well, again, you've got a shortcut. You don't have to worry about working out the rest of them because you've got the answers. Here's the square root of 3 over 2 that was right here. This one was negative. We just need to make the answer a negative. This one's 1 over 1. Okay, well, that's just 1. This one's 1 over 0, so it's undefined. There you go. All right, now I'm actually going to cheat just for a second. No, let's go ahead and stick with it. We'll come back to it. All right, if you're doing cosecant, I'll have to refold this one because cosecant is 1 over sine. So now we need this number. And then here's the question, though. Because cosecant is 1 over sine. But are there any new numbers in sine that's not in cosine? There's not, right? Because remember, you switch up the order. So when we go to do 1 over sine, we'll just cover that one up for a second. If they ask you for the cosecant of pi over 3, well, that's going to be 1 over square root of 3 over 2. But if you look at that one, we've got it right here, right? Because we just did it back here for this problem back in secant. So if this is 1 over square root of 3 over 2, we just did this work. We don't have to reinvent the wheel. We already know this answer is 2 square root of 3 over 3. Now, if we do this one, Right here. That's just 1 over 1. Okay, well, that's easy enough. That's just 1. And we're going to skip these two because we've got a 1/2 and a square root of 2 over 2. We can come back and get these down here because we kind of bled into this box. If we do this one, it's 1 over 0. Well, we know that's undefined. If it was 1 over negative 1/2. Again, we did the same thing with that one right here. 1 over 1/2 was 2. So if we just make the half a negative, like we did in this one, the answer is just going to be negative 2. So every answer that you've got in cosecant, you've already got the answer in secant. You just got to go back and find out where it is. So there's nothing new. Once you do a couple of these, again, there's nothing really new that they can throw at you here that you haven't already done here. And we can keep going down the list on this one, but it would basically kind of keep repeating. And the good news about cotangent, fold it back a little bit. Now for cotangent, I'm only going to go back to the tangent values that we had. Because again, cotangent is cosine over sine. So if we're doing the cotangent of pi over 3, we're going to do 1/2 over the square root of 3 over 2. But hey, look right here. You already got the answer right here for this one, right? We already did 1/2 over square root of 3 over 2. We don't have to do anything new. This answer is just square root of 3 over 3. Well, this one's going to be 0 over 1. We know that's going to be 0, so that's easy. If we do this problem, it's square root of 3 over 2 over 1/2. But we already did this problem right here. We know that answer is square root of 3. This answer's got to be the same answer. It's got to be square root of 3. So there's no new answer in cotangent that you already don't have in tangent. So again, once you make out this sheet, every answer that's possible is going to pop up. So you can just kind of keep going through these. This one, it's the same number over itself, so it's still just 1. This one would be negative 1 over 0. We know if 0 is on the bottom, it's going to be undefined. So every answer that's here, you've already done it back here. You just got to go back and find it. So when you're going through the homework, this should be like the easiest section of homework because I've given you every answer there can possibly be for secant, cosecant, tangent, cotangent, all those numbers. You've got every answer in front of you. You just got to look on here and find it. And people are like, really? I'm like, yes. You've got every single possible answer that's in front of you because once you've done a little bit of the work, you've done every single possibility of work that could possibly show up on this thing. So this is your cheat sheet when you're doing your homework. Hang on to it because this will save you a lot of work because, again, every possible answer that possibly could show up for any of these things that we're doing, you've got every answer right here in front of you.